So in this question, we have the scenario of a single phase supply of 230 volts, 50 hertz, connected to a compressor, which is essentially a motor. And we're told that the draw, as in the current, is 16 amps, and that the power factor of this motor is 0.82. And we're asked to calculate three values in relation to this. The first one is the real power, or true power, real or true power. And I'll use P for that. The second is the reactive or wattless power. And I'll use Q for that. And just as well, I'm going to put in the units for these because I find it very helpful. And then finally, it's going to ask us to work out the size of a capacitor in terms of kVAR that will reduce or improve the power factor to 0.95. But we'll deal with the first part A and part B. So just to recall, what we need to know for this question is we need to know about our power triangle again, which relates to three powers: our real power P, which is equal to V times I times cos theta, our reactive power Q, which is V times I sine of theta, and our apparent power S is equal to V by I. So we look at this first part here, part A. So we'll start this one up top. How do we get the real or true power in this situation? Well, we're looking for P. So we have V and I. They're already here given to us. And we just need to know what the power factor is. Or not the power factor, but this cosine theta. But cosine theta is our power factor. So we have all three values here. So we can say that our real power is equal to 230 times 16 times 0.82. And the answer, it's asked to work it out in kilowatts. So it comes out at 3.02 kilowatts. So that's our real power, this value here, P. So now we have to work out the reactive or wattless power. Now, we have a formula for that, Q. It's VI times sine theta. And if we look at this, we have V and we have I, but we don't know what sine of theta is yet. But we can get that. We know that our power factor is equal to the cosine of theta, which is equal to 0.82. That's given to us in the question. Now we can work out the angle that this power factor relates to as the cos inverse of 0.82. And that comes out at 34.92 degrees. So what that tells us is that the current is lagging behind this voltage by 34.92 degrees. And the reason I say lagging is because we have a motor which will be an inductive load. But to work out Q, we can now say it's 230 volts multiplied by 16 amps multiplied by the sine of 34.92 degrees. And we get out for that 2.1 kilovolt amps reactive, or kVARs. So we have A and B completed now. So what part C is asking for here is, how can we actually improve this overall power factor of our circuit? And by improve it, we want to move this number towards 1. Now the question is telling us, or asking us, to work out what size capacitor we need in this circuit in parallel with our motor that will actually improve the power factor to 0.95. Now, in your formula, in your booklet, in AC formula, you have a formula for power factor correction, and it's telling you that the kilovar rating of the capacitor is worked out as the kilowatts times the tan of the angle before power factor correction minus the tan of the angle after power factor correction. So when we look at this equation, we ask ourselves, what do we have? Well, we have kilowatts. It's up here. We have the angle before power factor correction, but we don't know the angle after power factor correction, so we need to work that out first. So again, if the power factor after power factor correction is going to be the cos of the set of that angle, and it's telling us it's equal to 0.95 from here, well, we can say then that theta 2 will be the cos inverse of 0.95, which works out at 18.19 degrees. So now we have this angle, we can pass it back into our formula and work out that the kilovar rating of our capacitor will be 3.02 kilowatts times the tan of 34.92 degrees minus the tan of 18.19 degrees. So that works out at 3.02 times 0.698, that's the tan of 34.92, minus 0.329, that's the tan of 18.19 degrees, and we get out 1.12 kilovars. So that would be the power rating of the capacitor that would increase the power factor from from 0.82 to 0.95 in this circuit.